Hello and welcome. In this video, we're going to do a series parallel example. In this case, it wants us to find the RT in kiloohms and the IS, the source current, in milliamps. And so they have given us the resistor values here and the voltage source. So we've got a 9-volt source. R1 is 9.1 kiloohms. R2 is 10.2 K. R3 is 6.6 K. And R4 is 11.2 K. And so we want to put those into a series parallel combination to get our total resistance here. So from our voltage source, that's our perspective, we'll travel up through, we have no choice but to go through R1. So as RT is equal to R1 in series with, since we had no choice but to go through that, it has to be in series with whatever comes next. After that, we come down here and we hit a node, so we'll open a parenthesis. We'll go down through R2, and that hits us back at that same node here. We'll say R2 is in parallel with whatever got us to that bottom node. So we go back up to the top one and see that we can go also through R3. That means R3 is the second side of that. Since they close back together at the bottom there, we had a second node down there that closes that parenthesis. We can continue on in a series path, no choice but to go through the next one, which is R4. And that leads us all the way back to our negative terminal. So we'll say plus R4. Right, so that is going to be our total series parallel resistance combination. We can use our Desmos to calculate that out. We'll say that we have R1, that's 9.1. They're all in kiloohms, so we can just leave the kiloohms off. Add that to, open a parenthesis here, we'll do our parallel, 1 over our R2 in parallel with R3, so that's 10.2 plus 1 over 6.6. We'll close that off, and we will add in our final series resistor of R4, that's 11.2. That's going to be our total series parallel resistance here. So RT is equal to 24.3 kiloohms, right? Since the other ones were in kiloohms, this one's also going to be in kiloohms. So that's going to be our answer for that one, 24.3 K ohms. And they wanted it in kiloohms, so make sure you're getting it into the notation that they're asking for these ones. It says, what is the source current, IS, in milliamps? And so we're going to take our total resistance and use our 9-volt source and Ohm's law. Ohm's law says that the current is equal to voltage over resistance. So we'll say that we have current equals voltage over resistance. We know our voltage is 9 volts, so I is equal to 9 volts divided by our 24.3 K ohms. Make sure we account for that kiloohms in this one here. So when we type that in, we'll say 9 divided by 24.3 times 10 to the positive 3. And that gets us a really small number. That's what we expected. We're going to put that into milliamps. So our IS, in this case, source current, we want it in milliamps, so we're going to move that back one space from that -4 down to that -3 location. So we're getting a 0 point, there's our new decimal point location, 370. And that's in milliamps. Right, we can leave that final 0 off. We don't need it there because it's not going to account for anything. And so we can just say that's 0.37 milliamps. Right, let us know if you have any questions.